So it's Leetcode problem 279, perfect square. So in this problem you are given one integer n and your task is to find the minimum number of the perfect square numbers whose sums are equal to n. Okay, you are only allowed to use perfect square number. So what is a perfect square numbers? Multiple by itself. Okay, like 1 is equal to 1 into 1, 4 is 2 into 2, 9 is 3 into 3, and 16 is 4 into 4, and 25 is 5 into 5. So only these numbers can be used to make the sum. So you can use the same perfect square multiple times. Okay, so you get a number n and you get a number n, and you can add perfect square numbers. You must make total sum is equal to n and find the minimum count of the numbers used. So you do not need to return the combination, only try the minimum cost. Okay, only the minimum cost. Okay, if we have, if n is equal to 12, see 1 4 9. Okay, perfect square is less than 12, so 4 plus 4 plus 4 12, so there are three numbers. Okay, if 9 plus 1 plus 1 plus 1 12, so there are four numbers. If 1 plus 1 plus 1 so on plus 1, so there are 12 numbers. Okay, if we have n is equal to 13, so the perfect square is 149. See, 9 plus 4 is 13, so there are two numbers. 4 plus 4 plus 4 plus 1 13, there are four numbers, and 1 plus 1 plus 1 so on, and 13, so there are 13 numbers. So 2 4 and 13, so the minimum number is 2, so the answer is 2. Okay, so the minimum number of the perfect square number and add up to the n. So say we can use the same square multiple times, and so we want minimum count. Okay, so if we have n is equal to 5 and squares are 1 comma 4. Okay, we have this square with this number. So see, we start at 0 1, we start at root node 0 comma 4 and take index 0. Take 0, index is 0 and square is 1 and target is 5. We have two options. Take is 0 5 comma 1 is 4. If we skip 1 comma 5. Okay, see, this side, left side is subtract 1, remaining target is 4. Okay, now remaining target is 4, and while because we are taking the square, so we reduce the target. So skip side, we move to the next square, that was 4, so the target is still 5. Okay, so because we are not taking current square, so we move to the next. Okay, in next we have 0 and 4. If we take 0 comma 3, and if we skip 1 comma 4, see, we subtract by 1, and in this right side we move to the next square. Okay, next is 1 5. See, if we take 1 comma 1, it was n because it was invalid, so we subtract from 1, so we subtract 4, so it become 1, and next index of the index is out of 1, so it was invalid. Okay, see, there are leaf nodes 0 comma 0, target is 0, so it was valid, so we are going to return 0. 1 comma 0, so the target is 0, it was also valid, so we are going to return 0. 1 comma negative 3, so target is less than 0, so it was invalid, so we are going to return a large number. So 2 comma 5, index of greater than equal to size, so it was invalid, so we are going to return the large number. So we count, say, take 4, take 1, we take 4. Okay, take 1, if we take 1 comma 5, so it was 1 comma 1, so and 1 comma 0, so the count is 1. See, count is equal to 1, take 1 plus 1 take 4 is equal to 2 minimum. Okay, so take 1 repeatedly, 5 ignore by min. Okay, so let's write down the code. First we make a function int solve int I int target Victor int and square. See, base case was be if target is equal to 0, so we form the sum exactly, so no more squares needed. So example c1 comma 0, so we are going to return 0. Okay, so in this case we are going to return 0. So if target is equal to 0, we are just return 0. If target is equal to 0, return 0. Okay, if base case was invalid, so if target is greater than 0, it was overshot and invalid. So if index is greater than or equal to size, no more squares left, it was invalid. So see example 1 minus 3, it comes here, so we are going to return 1 in 9. If 2 comma 5, so here also we are going to return 1 in 9. Okay, 1 in 9 is a big large number. Okay, if target is less than 0 or I is greater than or equal to square dot size, return 1e9. Okay, next is these options, take and skip. Okay, see left side we take current square, so subtract square of I from target, so we add 1, so because we use 1 square. See example this 0 comma 5, I take 1, so it becomes 0 comma 4, we continue. Okay, let's write int take is equal to 1 plus solve of I target minus square of I square. Okay, next is skip, and skip is equal to solve of I plus 1. We cannot subtract here, target and square. Okay, see in right side we skip the current square, so we move to the next. Okay, we move to the next index 1, that was 4. Okay, so the target is unchanged, it was 1 comma 5, so we skip 1. So we just return the minimum, return min take comma skip. So So see, among all possible paths, pick the one with the minimum square. Example, we have say 0 comma 5, left part is 5 and right part is 2, so the minimum is 2, so we are going to return 2. Okay, it was, and just we make this vector int square for int I is equal to 1, I is into I greater than or equal to n, I plus plus, yes, square dot push push back I into I and just return solve all 0 n and square. See, here we are going to prepare square is less than n and we start recursion. So why vector we are going to use vector? Because all perfect square are less than n. So see why we should, why this solve of 0 of n. So start recursion from the first square full target. Okay, I think it was work. Yes, see, so we cannot use recursion because there was a same repeated subprogram in our recursion tree. See, not t0, it was not full tree because they have repeated subprograms. Okay, we just solve multiple times in different parts, so same calculation repeat again and again. So that's why we are not going to use recursion, we will use memorization. Memorization means they stole the result of subprogram. Okay, it just stole, like solve of I and target. Next time we need same I and target, just return stored value, avoid repeated work. So make recursion, so it's make recursion fast and feasible. So let's convert this code in memorization. First we create a map of pair int comma int memo. Next we store in map if memo dot count I and target return memo of I target reuse. So here we are going to just reusing the answer. Okay, next we are going to return, first we store the answer memo of target is equal to main, take or skip. Here we store the answer. Next we just return memo of I and target. Yes, See, each node I and target check in memo first left branch take subtract from square from index same index and write skip next index. So return 0 if target is it was base case, and memo ensure any repeated node is calculated only once. Okay, now let's convert this code in DP because it was not, it's game a time execute no time limit. Okay, so we cannot use this code, it was time limited. So see, let's convert, now we convert this code in tabulation DP. Okay, first let me comment out this all, which function we are going to use this one. See, first we need target remaining sum. Okay, so DP array is look like this. First we need a target, so first we need target remaining sum. So DP array is like this, DP of t mean squares to sum t. Okay, see, t is equal to 0, DP of 0 is 0, target is 1, use squares is less than 1, so DP of 1 is 1, target is 2, use square is less than 2, so DP of 2, so on it's continue. Okay, next let's first initialize, first we create DP array. Okay, let's first create a DP array into so first we create vector of square is vector int square. Next loop for int I is equal to 1, loop start from 1, I into I less than or equal to n, I plus plus. So next is square dot push back I into I. This is for square. Okay, next we create a DP array, vector DP vector int DP of n plus 1 and initialize with 189. Okay, next base case, if DP of 0 equal to 0. Okay, DP of 0 is next 0. See, so here we are initializing with this dot. So here we are initializing all the large value. Okay, next base case is sum is 0, needs 0 squares. So see, large value to make numerator base case is 0, so base case will, so DP of 0 is base case. Okay, next this part, see this. So what here we are doing, we store all perfect square that was less than n. Okay, so example, if n is 5, we store 1 and 4. Okay, that's we are doing there. Next array. Next was see, next we fill DP array with bottom up. Some this is sum from 1 to n. See, let me write first. For int t is equal to 1 and t is less than or equal to n, t plus plus for out of sq is to square sq try e square is that was less than n. Okay, here we are trying e square sq u a r e square. If cannot use square, so that was greater than target. Okay, we cannot use. If sq is greater than t, just break. Okay, just break. Next, dp of t equal to min dp of minimum and dp of t comma 1 plus dp of t minus sq. See what we are doing here. First is t is equal to 1, square is less than 1, so 1, so dp of 1 is 1 plus dp of 0, it was 1, target 2 is square is less than 2, so it was 1, so dp of 2 is 1 plus dp of 1, so it was 2. Next is t is equal to 3 and square is less than 3, so 1, and dp of 3 is 1 plus dp of 2, so it was 3. t is 4, now square is less than 4, no, so 1 comma 4, it will be like 1 comma 4 and dp of 1 comma 4 and dp of 4 is minimum 1 plus dp of 3, and next is 1 plus dp of 0. Next is see, minimum is 4 comma 1, so the answer is 1. So see, t is 5, square is less than 5, so 1 comma 4 and dp of 5 is minimum 1 plus dp of 4. Next 1 plus dp of 1, so the minimum is 2 comma 2, so the answer is 2. Okay, so we just going to return the dp of n. dp of n is minimum number of squares. Okay, and that was is 2, so the answer is 2. We just return dp of n. Return dp of n. Oh, maybe it was right or not. Yeah. So that's all.